Defining a coordinate system allows you to describe a vector in a different way. Vector A, shown here for example, could be described as going 5 units in the positive x direction and 4 units in the positive y direction. You can represent this information in the form of two vectors and label them AX and AY. Notice that AX is parallel to the x-axis and AY is parallel to the y-axis. Now if you add AX and AY, the resultant is the original vector. You can therefore conclude that a vector can be broken into its components, which are a vector parallel to the x-axis and another parallel to the y-axis. This vector equation is always true. The process of breaking a vector into its components is sometimes called vector resolution. Notice that the original vector is the hypotenuse of a right triangle. This means that the magnitude of the original vector will always be larger than the magnitudes of either component vector. Another reason for choosing a coordinate system is that the direction of any vector can be specified relative to those coordinates. The direction of a vector is defined as the angle that the vector makes with the x-axis, measured counterclockwise. In the coordinate system here, the angle 0 tells the direction of the vector A. All algebraic calculations involve only the positive components of vectors, not the vectors themselves. In addition to measuring the lengths of the components' vectors graphically, you can find the components by using trigonometry. The components are calculated using these equations, where the angle 0 is measured counterclockwise from the positive x-axis. The sign of a component depends upon which of the 4 quadrants the component is in, as shown here. When the angle that the vector makes with the x-axis is larger than 90 degrees, the sign of one or more components is negative.